Hello, Algebra 2. Here we go again. So what I want to let you know, you may not have missed everything, so you might want to fast forward to just the parts you need to go over because this video may be kind of long to go through both sides of the practice exam. So let's get into it. Write log 27, base 27 of n equals 2/3 as an exponential. So remember, it's all about the base. You start at the base and circle around. What's on the other side is always that unknown exponent. So 27 to the 2/3 equals n. That would writing it as an exponential. Now, to evaluate, we did this in chapter 5. You start with the bottom and work up. So that 3, which is really a 1/3, 27 to the 1/3, that's finding a root. It's like finding the cubed root of 27, which is going to be 3. And then we do the top number, which is a power. So 3 squared is 9. Okay? Then we are going to simplify. If the base of an exponential equals the base of the log, they undo each other, and you're left with just 3x. So here we have the base of the log is 6, but we can turn 36 into an exponential as 6 squared, and then there was still a 2 up there, so times 2. Once we have the base of our log and the base of the exponent the same, they undo each other, and our answer is 2 times 2, which is 4. Now we are going to show our log properties by expanding these using the clues, log base 2 of 5, log base 2 of 7, and if necessary, log base 2 of 2, which is 1. So 25, using 5, 7, or 2, can be rewritten as log base 2, 5 squared. Remember, when we expand, we want our argument to be as simple as possible. So that 2 is going to move in front with our power rule. So I have 2 times log base 2, 5. So that's going to be 2 times. Now we substitute. Now that we've done all our expansion, I'm going to plug in 2.32. Those are the clues they gave us. And 2 times that will equal 4.64. The next one, we have log base 2, 35. Well, that's the same thing as log base 2, 5 times 7. Now we expand. So when you expand, it's an Oprah moment. Everybody gets a log. You get a log. You get a log. So we get log base 2, 5, and 7, and multiplication goes with addition. So now we substitute. This is our 2.32. This is our 2.81. And when we add those together, we are going to have a 3 and a 1 and a 5. And our last one is log base 2, 7 divided by 5. So again, everyone gets a log when we expand, and remember, division goes with subtraction. And so now we substitute. This will be 2.81 minus 2.32. Okay, so that would be 0.49. I'm hoping, to be perfectly honest. I should probably double check that. So let's see. Work it off to the side. Yep, 0.49 was right. There we go. And so that would be, make sure you show the expansion property because it's not just about the decimal that we're looking for. All right. Use properties to expand, kind of the same concept without the substitution. So hopefully you notice there are 3 terms here, 12 times x divided by 3. So 3 different terms. That means in my Oprah moment, there's going to be 3 different natural logs. 12 and x are joined by multiplication. Multiplication goes with addition. Y is in the bottom, so it gets subtraction because division and subtraction go together. And that would be your final answer. natural log of 12 plus natural log of s minus, if I can put that away, natural log of y. All right? Okay, use properties to condense. So now we're going in the other direction. So first thing you do, if you're playing the video backwards, is we put all our exponents upstairs. So that gives me log base 10, because you don't even see a base. 2 cubed is not 2 times 6. 2 cubed is 8 minus log 2 plus log 4 to the 1/2 is another log 2. That was kind of a silly problem on my part. Those would basically cancel, and we have log 8. All right, now expressing in terms of natural logs. So please make sure you read whether we ask for natural or common. Natural log is your ln. So that means we're going to have an ln on top. This is different than your expanding and condensing properties. Everyone gets a natural log. The subscript goes downstairs. That's your base. The base is always down. And the 4 goes upstairs. All right? And that's it. That's now something. If it had asked for a common log, it would be log 4 over log 18. Okay, now we're going to get into solving. Okay, so remember there's 2 types of exponentials, same base or not the same base, where you have to write it as a log. So we're going to start off with this exponential. They both have a base of 3 that we can write each one as. So 9 is 3 squared, and the 5x minus 12 just goes along in parentheses. 27 is 3 cubed. Once we rewrite it with the same base, we can sort of cancel these bases, and since they're already equal, and just set our exponents equal. So I'm going to distribute the 2 so that we get 10x minus 24 equals 3. And that gives me 10x equals 27. And then we can divide by 10. So x equals 27 over 10, or you can leave it like that, 2.7, I don't care. Okay, so that's writing an exponential as same base. The next one is what we would call unbalanced. That's how I feel some days when there's too much to do. Okay, unbalanced logs. So the strategy here is to write it as an exponential. And remember, it's all about the base. So 3 cubed is going to equal 4x plus 7. 3 cubed, which equals 27, that equals 4x plus 7. And then all we have to do is solve for x. So I can subtract 7 from both sides, and we get 4x equals 20. So x is going to equal 5. All right, the next one, it is going to turn into an unbalanced log as well, but first we have to condense this into one log. So addition, remember, goes with multiplication. So we condense it into just one log, log base 2, and we multiply. So this will be x times x plus 2 equals 3. So make sure if there's a minus there, you want to do division. Since that was addition, that became multiplication. Now, we have an unbalanced log now. So we're going to write it as an exponential. So 2 cubed is going to equal the argument here. So remember, 2 cubed is 8 equals x squared plus 2x. So I end up with a quadratic. I can set it equal to 0 plus 2x minus 8. I can factor. So this will be x plus 4, x minus 2. So our potential answers are x equals negative 4 and x equals 2. And when I look back at my original problem, if I were to plug in a negative 4, it would make my argument negative. So I only have one answer of x equals 2. All right. Now we have a natural log unbalanced problem. So how do we get rid of ln? We're going to write it as an exponential. So I think some of you prefer to just kind of take the e of both sides. Remember that e is the base of an exponential, so that meant my two terms that were there become exponents. But e and ln cancel, so I have 3x plus 1 equals e raised to the fourth. And if I want an exact answer, I'm just going to isolate x. So the first thing I'll do is subtract 1, so that I have 3x equals e to the fourth minus 1, and then I can divide by 3. So this will be e to the fourth minus 1 divided by 3. All right? Now the ones that everybody likes, we have balanced logs. So you just cancel those out, and we have 2x equals 4x plus 6. So we want to isolate x. So I'm going to subtract 4x from both sides. That gives me a negative 2x equals 6. So x equals a negative 3. But if I plug a negative 3 back in, it's going to make my arguments negative. So that is extraneous, and that leaves me with no solution. All right, our last one is an exponential that I can't write with the same base. So your strategy is to write it as a log. So how are we going to do this? So this is going to be log. You have to write the log. The base is 6 of 38 equals 3x. Now, the problem here is log base 6 of 38 is not a number that I could readily figure out. So we are asking you to write that with your change of base. So that would look like log 38 divided by log 6, that's using the change of base, equals 3x. And so then if I multiply both sides by 1/3, I get my answer. So x equals log 38 divided by 3 log 6. And that is it for that side. I hope that is helping. All right, the back side. This seemed to be the more challenging side in general. So the inverse. Remember that logs and exponentials are inverses of each other. That's why you have things that undo each other. So your answer, since this is an exponential, your answer should be a log. So the first step is always switch the x and the y. So we have it like this. Then our next step is write this as a log. So you have to write the word log. We start at the base. You always go to the other side of the equal sign and circle around. So log base 5 of x equals y plus 2. And last step is we're just going to isolate y. So we're going to call y f inverse. So we're going to use our inverse notation. And so the answer will be log base 5 of x minus 2. And on this one, we were okay with you not using the change of base because you're just coming up with an inverse function. We're not actually solving for x or a particular time. Now it wants us to, given 2 points, write an equation, an exponential equation. So I like to put a little xy above each one of these. And we're going to plug in our points. So I have y is 16 equals a times b raised to the 2 squared. And the next equation is going to be y is 2 equals a times b to the 5th. Now, since everything is multiplication here, I'm going to divide both sides against each other. That is going to give me 8. My a's will cancel, equals b to the negative 3. So remember, a negative exponent means a fraction. So this is 1 over b cubed. And if you don't, since we want to actually solve for b, so I'm going to take the reciprocal of both sides. I'm going to do it over here because I'm running out of space. So I have b cubed equals 1/8. So I took the reciprocal of both sides. Now when I go to do the cubed root, we find out that b will equal 1/2. But we are not done. So we have to take that and plug it back in because we still have to solve for a. So I'm going to plug it in up here. So I have that 16 equals a times 1/2 squared. I'm plugging it into this equation here. So 1/2 squared is 1/4. Sorry, this is all over the place. I did not give you guys much room here, did I? So I have 16 equals a times 1/4. So we multiply both sides by 4, and we get that a is 64. Now, some of you just found a and b, and that was great, but you didn't put it all back together. So our equation should look like an actual equation. So y equals, instead of a, we substitute 64. Instead of b, we substitute 1/2, and x stays as our exponent. That would be our equation. Okay, now we have our inequalities. So we start off by isolating the natural log. So I'm going to have 3 natural log of x is less than or equal to 12, because I added 4 to both sides. Then I'm going to divide by 3, so that I have the natural log of x less than or equal to 4. So we have a log, and we want to undo the natural log. So remember, e is a base of an exponential. So these two numbers that were there in the inequality become exponents. We're raising them with a base of e, because that will cancel, and we're left with x less than or equal e to the 4th. So if you have a log, you undo it as an exponent. And since this was base e, we can undo it with e. All right, now we get into our word problems where you definitely want to have a calculator handy. One of the things I noticed is people had trouble just translating their percents into decimals. Always move your decimal place 2 places. So it'd be 1, 2. This would go here, and so we have 0.025 is going to be our rate. All right. A car valued at $45,000 depreciates at a fixed rate of 2.5 per year. After how many years, so we're going to try and solve for t, will the value have depreciated to 20,000? So 20,000 is what it will be after a period of time, but initially it was 45,000. That's your principal. And 1 minus 0.025 raised to the t. So the first thing we like to do is isolate the exponential. So we're going to divide both sides by 45,000. So that goes away. All those zeros will cancel. And 20 divided by 45 is 0.4 repeating. So I'm going to write down 0.44. I'm going to give us 3 of them. Then I'm also going to simplify. 1 minus 0.025 is 0.975 raised to the t. Here's the problem that we want to solve. This is why we have logs, because it solves for an unknown exponent. So I'm going to turn this is an exponential equation, we're going to turn it into a log. So the way that works is we have to write the word log. The base is 0.975 of 0.444 is going to equal t. And wouldn't that be nice if we were done, but we don't know what that equals, and we want an actual time. This is why we use the change of base. So it's going to be a log over a log. The subscript or the base always goes downstairs. The base is down below. What's up top is 0.444, and that we can enter into our calculator. So we have log 0.444. I could have done second answer, but that's okay. Close parenthesis, divided by log 0.975 gives me approximately 32 years for my car to depreciate to $20,000, or somebody's car. Obviously not my car. I don't buy a car that much. All right, so if you end up with a exponential, you have to write it as a log and use change of base. Now this next one, Jamila invests $12,000 in a college 529 plan that earns 5% interest compounded continuously. That's the key that tells us we're going to be using PE to the RT. All right, so as an exponential function, A is going to equal 12,000. E to the, it was a 5%, so move your decimal 2 places, 0.05t. That would be the equation we're going to work with. Okay, now we want to know how long it will take for her investment to triple. So if her investment is $12,000, the amount will be $36,000 when it has tripled. So we set it equal to that, e to the 0.05t. You always want to isolate your exponential before anything else. So we go through and divide by 12,000. This will always end up, since we tripled it, it'll be 3. If we had doubled it, that would be 2. It'll always be that way. E to the 0.05t. And I think you guys are getting pretty good with these E problems. How do you cancel E? I hear you all saying, take the natural log of both sides. That natural log always goes in front of a number. So that's going to leave us with the natural log of 3 equals 0.05t. And since we're trying to solve for t, we can then just divide by 0.05. And then we go to our lovely calculadora. So this will be ln of 3 close parenthesis divided by 0.05. 21.97. So let's just round it to 22 years. Okay. And our last one. If you invest $500 in a stock that promises a return of 3.5%, so if I move that decimal 2 places, 0.035, that'll be my rate, compounded quarterly, quarterly means N is 4, monthly, N is 12, because there's 12 months in a year, so please pay attention to when it says compounded by what amount, because it'll change for every problem. What will your balance be after 20 years? So that's going to represent our T. Because it mentions a particular amount of time it's being compounded, we're going to use this formula. P1 plus R over N raised to the N times T. So the amount is what we want after a certain amount of time. The initial investment was 500. 1 plus the rate was 0.035 divided by 4, and then N times T would be 4 times 20. And I recommend you simplify things before you plug it into your calculator. So this will be 500. We have 1 plus 0.035 divided by 4, which is a lovely 1.00875 raised to the 80. So again, you're going to enter 500 times 1.00875 caret 80. And what you should end up with, 00875 caret 80, is a lovely, how much will you have? Drum roll please, $1,003.82. On these ones that involve money, you should always include 2 decimal places for your cents. All right, there is practice exam 2. I hope that was helpful for you in preparing for the retake.